Alright, baby, we are live.
Live in Largo, Florida.
Shh, I can't know that. Alright, so you haven't unfortunately been able to get any coding in today yet, so there's not really much to update on from yesterday, right?
No, I just haven't been feeling very well, so.
But you're gonna code after this.
Yes.
Good. Alright, so let's get back to where we were at yesterday in terms of the JavaScript. Now, I'm going to go to beta.freecodecamp.com. You can get your notes? Your notebook?
What about it?
You don't have it.
I don't normally take notes. You go too fast for me.
Okay. Neil Floyd, welcome. Fair enough, fair enough. Alright, so, actually,
If I need anything, I'll just go back to the video.
we're good. Alright, so, here we are. Put on my glasses. Let's get set up here. Alright, I'm tired. So, can you turn the AC on before we get going? So I'm like burning up
I'm
already.
really comfy.
Alright, I'll get the AC.
Thank you.
What are you doing, Achilles? Alright, cool. So, changing if-else statements. So last time, let's do a little bit of review. So last time we were talking about if statements, then we were talking about else if, and then we were talking about else statements. Explain to me how all three interact.
Well, an if statement is to find out if it's true or false,
And if it's true, what happens?
it runs.
Okay.
And then if you have an if-else statement,
Else if.
I don't know, I thought it was,
Else if.
and there's an if-else.
No. There's an else if.
Okay. An else if statement is, well, it's kind of like, so you can have an if statement, and if that if statement's not true, then there's the else, and then the else would run.
Yes. Now, what about the else if?
The else if, I forget that one.
So the else if is an if statement that only runs if the if statement above it fails. And so if it goes if, else if, else if,
How is that different from what I just said?
because you said else statement. Alright, so
What?
it's alright.
Wait.
Alright.
So,
An if statement evaluates if something's true or false, and then if it's true, it runs that code. Next, an else statement is the last statement. You only ever have one else for each if bundle. And that will only run if everything else fails. If all the if fails, if all the else ifs fail, it will run the else. Okay?
okay, so you can have an if, an else if, and an else.
Yes. And so it will only run the else if all else fails. See what I did there?
Yeah.
All right. And so an else if runs if the if above it runs. So if it goes if, else if, else if, else if, that third else if, the if and the two other else ifs all have to fail for it to hit that third one.
The third, just else.
Else if, yes.
No, the else.
There's only ever going to be one else for each bundle.
Okay, but you just said, I thought you were talking about an if, else if, and an else.
I'm talking about understanding how they all work together. So in the example where I have an if, else if, another else if, another else if, to get to that third else if or the fourth one, these first three have to fail.
Okay, I get that.
Okay, good. All right, so we're gonna.
But what about the else by itself?
The else won't run unless they all fail. So if all, like, so say there's
I
5
got
total.
it. Okay.
Okay. What are you fucking looking at me like that for? Try to help. Alright, so in here the
Hey everyone.
welcome. The objective here is to.
Are you showing everyone off your hand?
No, should I?
I don't know, you're holding it in front of you.
I was looking at it. It looks pretty bloody still.
Get it away from me.
Yeah. David Yang, welcome. Krishna, Jordan. All right, so let's go ahead and chain some of these together. So the first thing, remember logical order. If we're checking, we want to see how large a number is, starting from smallest to largest. If we're doing less than. If we want to do largest to smallest, we do greater than. In this case, we always start with an if, right? And so if,
we always start with an if in JavaScript or
in any language which you're using a if statement.
okay.
What?
Of course you're gonna use if you're using an if statement. Do all statements start with if?
No, in a conditional statement, you will always start with an if and never an else if or an else. Yes.
Okay.
How did the doctor visit? What? It went well. Let me see. I'll show you guys real quick before we dive back into. If you can see here, you can see they took the stitches out of my wrist.
I can't see it. What are you doing?
They took the stitches out of my wrist there, and then my finger. It's a little bloody, but they took the stitches out of there, so the bandages are off, and now it's just gonna take a couple weeks to heal. But all in all, it looks like the procedure was a success, and you all won't be calling me nubs anytime soon. All right. Anyhow, let's get back to it. So in here, we're gonna start with the if statement. We're saying, look, if our parameter that we're passing in is less than 5, we want it to return tiny. Else if, because if that one fails, we want to have another one that goes else if the number is less than 10, we want it to return something else. And the else if will only run if the number fails, right? So if the number is 6, it will return small. Else if again, if the number is less than 15, we'll return medium. And it's only going to be that if the other two fail. Else if
Missing the L.
yeah, sorry. Else if the
Not too sorry, honey. What? We're a cute couple.
else if
My baby.
the number is less than I got one good hand. Alright. Alright, so else if the number is less than 20, we're going to return large, right? And then now for our last one, because now we're saying for all other cases that doesn't match this, all our statements here, all our cases fail, we have an else that says this is basically for everything else. And in here, we're going to return huge.
You're missing a if statement in front of.
No, remember it goes if.
Oh yeah. Okay.
Okay, so let's do if I say the number 3, what's it gonna be?
Tiny.
And if I say 21, what's it gonna be?
Huge.
Good. And if it's 13?
Medium.
Good. All right. And that's because on 13, this is gonna fail. This is gonna fail. And then this one's gonna pass. Good. All right, basic JavaScript, golf. This one I remember doing back, I don't know golf, and so it was confusing, so it might take a second. So Par and strokes will be numeric and positive. In the game of golf, each hole has a par, meaning the average number of strokes a golfer is expected to make in order to sink the ball in a hole to complete the play. Depending on how far above or below par your strokes are, there is a different nickname.
Yeah. Eagle, birdie, par, bogey.
Your
Double bogey.
Your function will be pass par and strokes arguments. Return the correct string according to this table, which lists the strokes in order of priority, top, highest to lowest. All right, so this is a good example of putting it all together. So right now they're giving you, they don't really tell you exactly what to do. These are all our tests that need to pass, and we have to write our logic so that this does work.
Okay.
And this is what's kind of to dive a little deeper than necessary. This would be a great example of test-driven development. So you write tests that these would pass for. Passionate living. We take questions at the end of the sort of tutoring session. So just hang out for a little bit, and if you guys have any questions, you're still here. We'll answer them for about 10 or 20 minutes. All right. So par is the average number of strokes, and strokes are how many it took, right? Do I understand that correctly? All right, so should the strokes, so we could start
if strokes is less than 1.
Okay, so I'm gonna let you guide this one. So if strokes is less than 1 or equal to 1?
Equal to 1, it's a hole in 1.
Return hole in 1. Alright, cool. So let's run that, see if that passed. So it passed for our hole in ones. So that's good. We're on the right track. So now what do we do for when it is eagle? What is this? What was the next statement that we
So eagle looks like it's...
But tell me the code that I need to write.
I don't know. Is it going to be an else if?
Yeah, because if it's not a hole in one, and remember we were talking about logical order, so we're starting from the...
Okay, so you don't want to use just a bunch of if statements?
No, the reason you don't want to use a bunch of if statements is because it would run them all. And you could actually theoretically hit a bunch of them when you don't want to.
Gotcha.
So it makes your code faster, and it also is better because you could get multiple results when you don't want to, and it could change your code. Because maybe instead of returning hole in one, we actually set strokes to something else, to another value, and then it hits another if statement that sets it to another value again.
Okay. Sorry, something hit my leg and I had to make sure it was a cat.
So we have an else if here. And what we'll need is, so this is saying if strokes is less than or equal to par minus 2, it's equal to eagle. See, I don't necessarily like that they actually write this out here like that, but you see the table here?
What?
So what do we write in this else statement?
Well, they already have it laid out for you, which I find interesting. But it's probably because a lot of people don't understand what a par 2 is. Because all the other ones...
So in this case, if strokes is less than or equal to par minus 2, we want to return eagle. And we can run this real quick to see that it works. So, all right, cool. More of our tests are golden. These are passing for our eagle. Now, what about the next thing would be another else if, right? So we're checking if it's not a par 2 and it's not a hole in one, I guess that'd be a birdie, which is in my eyes like a par 3 or something. I don't know golf, but hey Milo, strokes. All right, buddy, come here. Come on, Milo. We're doing a live stream. Come on, buddy. Milo.
Hi, Baba.
All right, come on. You can lay in Daddy's lap. So if strokes is exactly equal to par minus 1. Now the reason we're doing exactly equal is to check two values. What are they? Two things, rather.
See if it's true or not true. To being true.
Our statement, we're checking if it's true, but we're using triple equals, the strictly equal operator, to see the type and the value.
Oh, okay.
Now this could pass with a double equals, but it's just better to pass in a strictly equal value. Milo, lay the fuck down. Alright, so return. Alright, buddy. I don't know if you guys can see this, but I got a cat over here rubbing his head on my fucking hand as I'm trying to type. Alright, so return birdie. Alright, so now we're going to do another else if, right? Because we're going to see if strokes is actually equal to par. Because I know that if strokes is equal to par is the average, right?
Right.
And strokes are how many took. So if that, we're just go ahead and return par. Milo, get your butt out of my face. God, my finger hurts. Alright, else if, and you see we're writing quite a bit of code right now to get what we want. And sometimes it goes like this. There's other things called switch statements, which we'll look at soon, that will kind of be like an else if but different. Anyhow, so else if the strokes is equal to par plus 1, we want to return bogey, which apparently means you're just below average, as I understand it. Else if
I'm not desperate, go home.
strokes is
Just
equal.
go home. Don't you want to go home? Go to your home.
Are you too good for your home?
You do know who I'm quoting.
Alright, so if you get plus 2, it's called double bogey. And finally, in our last statement, it's going to be an else statement, right? Because we've eliminated all the other cases. So it can only be...
Go home.
Yeah, it could only be return, go home. Exclamation point. Milo, go kill the seagulls. You're a good boy. Alright, so here... we've now set up a small algorithm, or a small, you can call this algorithm if you want, a small function that, based off of, that will calculate golf score, as long as we put in how many strokes and how many, what the par is.
Yeah.
And that will tell us what we got. And we'll never have to rewrite it again, we'll just have to call it. Like we would normally right here where we call this function. And if this was like a web application, these numbers here would be inputs that we would get the value, and then we would paste them into here, if you will, and it would then run our function to give us a return. Cool. Super cool. So now we're going to, I thought they might be going with this. So now we're going to be talking about switch statements. So, I've also done this like twice. So, I usually know how they structure these things. Milo, get out of here. He never comes in here except when we're filming. He's like, he knows.
He's like, I want to be a TV star. YouTuber.
Yeah. Cat-tuber.
Cat-tuber.
Alright, so there's these things called switch statements, which what they do is it's kind of like a shorthand if statement that checks for particular values. So in this case,
more particular than an if statement.
No, it's just a different way at the end of the day. And if you, it's better to write a switch statement instead of a bunch of if statements if you're checking for an exact number or an exact thing. So if you have a bunch of if statements, you should probably use a switch statement. Does that make sense?
Okay.
It's just better suited than an if statement. You could do
a bunch of if statements or a bunch of else if statements.
A bunch of if else if statements, because then they're all chained together, right? So you should look into a switch statement. The way the cat should have his own show.
He kind of does. He shares a channel with his two brothers.
Yeah, maybe I'll have a cat coding section. I do have a video where I tried to use the cats in a coding and it didn't come out very well. I might release a blooper reel at one day.
Yeah, just fucking
Milo, come on.
Milo.
Yeah, there you go. Good boy. All right, so in this case, the way that we set up a switch statement is we use this word switch, and we pass in the value that we're checking. So let's say we have a variable that we're checking. In this case, it's a parameter, val. We use the keyword switch val. And so what's going to happen is we set these cases. These are kind of like our if statements, except we're checking the value. So we're going to say case, and let's look at our test. So case 1 means if the value is 1, we want to do some stuff. In this case, we want to return alpha. Or actually, we want to set answer is equal to alpha.
Mm-mm.
Oops. So answer is equal to alpha. So, make sense so far? So, in our switch statement, we're checking a parameter. So let's say this is 3. Nothing would happen yet, right? But if it's 1, it's going to set the value of answer to alpha.
Okay, so it's very specific.
Yes, we're checking a value of something and seeing if it matches the case.
Okay, could you do a less than and greater than and equal stuff in switch statements?
Yes. Although typically that's not why you do it. It's usually like when you have a set amount of outcomes. So like we could do like case 1 minus 2 and it's -1, it returns alpha. So we could do it like that as well. But you're not checking, you could do it, but usually you're checking for a specific value in a switch statement most of the time. So here we have answer is equal to alpha. Now we have to use this break keyword. The reason that we use it is because otherwise it will keep running all the cases. It doesn't know to break out of the switch statement.
Oh, that's interesting.
Yeah. Now the next thing that we can do, we can have as many cases as we want. We have case here. So in case 2, if the value is 2, what we want to do is we want to set the answer equal to beta. And we have to use a break statement here as well, or it'll keep checking the answers. And it's the same sort of stuff. Is the reason you do else ifs is so that it doesn't reset the value. Here, it's not an else if, but they're essentially all ifs, and you have to break the cycle, the switch, by using the break keyword. Otherwise, it'll go on indefinitely.
So it'll just keep going over case 1?
Yes. Sort of. Just use break. That's the gist. Just use break. But it wouldn't necessarily keep going over case 1, but it will continue going through the rest of the switch statement. So if we have 100 switch statements, what this break keyword does, we haven't used it so far, but what it does is it breaks out of a loop. It breaks out of your if statements. So we haven't got to loops yet, but say we were looping for 10 times, where we're going to run our same code 10 times. It's called a for loop. And in there, it checked an if statement. When it hit 5, we set our value. And we knew that was all we wanted. We only wanted to go till we hit 5, but we had to run it for 10 for some reason. We would use the break keyword to break out of the loop. And so in that if statement, so that it wouldn't run the rest of the for loop. And that's what's going on here. All right. I get it. It's new stuff. I get it. All right. So case 3 And here we're going to say answer is equal to gamma. And then we have to break out of it. And let's see, do they have us use, I don't think they have us use default. And so we'll just set case 4. They're going to introduce it in the next section. Alright, so there's also a default similar to the else. But we haven't got to it yet, so I'll wait. So answer here is equal to delta. Oops. And let's go ahead and break now. Alright, so in our switch statement, if we have a value of 3, what is our answer?
Gamma.
Gamma, good. And then we break it so that if we set answer to 4, for instance, or value to 4, it wouldn't change our situation. Change our objective. But break takes us out of the switch statement. That's what it does. Same thing with for loops and while loops and things like that. But we haven't got to that yet. Alright, so we just covered a switch statement. Now there's a default, which is essentially the else of switch statements, where if all our cases fail, we use a default and go from there.
Oh, okay. So default is the
default value if all the cases fail. So
okay,
it's the else.
Yeah, okay. It's else.
Alright, so in this case...
I thought you were just saying default. I was like, what?
No, so in this case, we have our switch statement, and we pass in the value that we're checking. In this case, it's val. And we have a case, which in this case is a character A. And we are saying, hey, if A is there, our answer is equal to apple. An example of this is maybe you made a test and you had A, B, C, D, or E.
E, F, G.
Yeah. And if they didn't put one of the answers, the default might just be 0. Like, and you're just, the answer, if it's correct, you get a point. If it's not, you don't get a point, or you get negative points. And if you don't answer at all, you definitely don't get any points, right? So that's kind of how you could look at a switch statement as kind of a multiple choice. It's essentially a multiple choice with a default if you don't answer the question or it doesn't match anything. So in this case, answer here for A is for apple. Do another case. Oh, and then we break, right? And then we do another case. Milo, you are driving me fucking nuts, man. And B. In this case, B is equal to the answer. Okay, Milo. The answer. You guys see this shit? You're like standing on top of my fucking hand right now. Alright, so.
He's like, I want your hand to be better, Daddy.
So in this case, the answer here, B is for bird.
B is for Billard.
And we have to break the switch statement again. And then we have case C. So if our val is C, it's the answer here is going to be cat.
Cat, no.
And so
Break.
we break, that's right. And then if we don't do any of that stuff, we use a default statement here. And we say answer is equal to stuff. And there's no break because it's the last one. You can use a break if
You used a break on the other one.
but it wasn't the last one.
Yeah, it was.
No, the default wasn't the last.
Oh, the default.
So you don't use it on there. Traditionally, you always use it.
Defaults don't need breaks.
No, but I
How do
believe
you
I
know?
believe it's good convention to have breaks in there, but it's optional. I'd have to look up if it's the current good convention or bad convention to write that in there, but
Where do you look that up?
Google. That's Stack Overflow. I don't know. I couldn't tell you. All right, so multiple identical options in switch statements.
Maybe we can make that website.
So let's say that, remember how we had, all right, have a good one, Neil. Remember when we had ors and ands and things like that? Remember the ors?
The and,
So,
and the or.
Yeah. So let's say we wanted to get a number 1 or 2. And we wanted we were okay with either number, and it returned the same thing. So in an if statement, we use or. In this case, we would actually just set up multiple cases and then just have one set of logic and then one break. So in this case,
So it's a little bit more specific. There's no... Oh, well, I guess there is.
So if let's set up our switch statement again. Milo. All right, buddy. You get in the way. So switch. So in our switch statement here,
oh, you're so in the way, Milo. You're just totally in the way.
if our case is 1, and then we want to check, we want for 1 to 3 to return low. So instead of writing a bunch of return low, break, what we can do is case 1, case 2, case, and on the last one, case 3. And in here, we can say result, or answer, is equal to low. Or capital low. And then break. So
you don't need mid?
Well, we're going to do that next. But this is an example of having multiple cases with only one return.
Oh, okay.
All right, cool. So now, if we wanted to do case 4, 5, and 6,
and these are all supposed to be colons, not semicolons?
yes, semicolons ends things. In this case, a colon is. It's very rare that you're going to use colons like this. It's really only for switch statements and then later on for objects and things like that.
Okay.
Most of the time when you're organizing code, you're going to be using brackets. Switch statements are a little unique in that fashion. So here, we're going to set our answer equal to mid. And finally, case 7, or better yet, right, we learned default. So if it's not mid, and it's not, and let's not forget our break, right?
Yeah, but don't forget to do 7 through 9.
But we can, based off what's going on here, if it's not 1, 2, and 3, and it's not 4, 5, and 6, we can default it to high. Or actually, no, we can't, because what if they put in something that's not that, right? So I was taking a little bit of liberty with what they were asking. But let's say we put in hello, it's still going to return high. Which you may be high. Do that. Alright, so case 7. Case 8. Case 9. And here we're going to set the answer is equal to high, and then because it's not a default, we're going to use a break. Yeah, let's run this. Make sense? Checking a bunch of values and return, if it's any of those, we're returning the same result.
Can you use strings and switch statements?
Yeah. You can use strings, you can use booleans, you can use any type of variable. We just did it a second ago when we said A is, if it's a character A, it's apple. Remember that?
Yeah.
Yeah, that was a string. So here, we are going to replace this if-else-if block with the switch statement. That's the task right now. So, and you can see that when they're all kind of similar, like you can see when you'll need to switch it up. So we have this val, and all we're doing is checking the val throughout the whole thing. This is a good indicator that you probably should have a switch statement. And then we have a return answer, which we can leave it there as well. So in our case, Samuel, Phils, and Josh, just wait like 15 minutes, then we'll answer questions, guys. So here, we're going to create a switch statement, which, remember, takes the value that's in here and it examines it, and then we're going to write a case. And we're going to say, look, if this case is Bob, we're just going to go line by line. We want to go ahead and set our answer equal to Marley. And then we want to break. Right? We're now converting our...
Yeah, but I don't see how the switch in this case, like, why would you use the switch in this case? Why not just leave it with the val and the answer?
Right now, it's a matter of preference. It really is a matter of preference when it comes to switch or else ifs.
What? How could it be a matter of preference? What are the extreme differences? What are the benefits? What are the...
I mean, right here. If you have... I'll read what it says here, but it really is a matter of preference. So if you have many options to choose from, a switch statement can be easier to write than many chained if and else if statements. So it really just depends on the user and what you prefer. I personally very rarely write a switch statement, but that's also because I'm not in a situation where I'm writing a bunch of if and else ifs. If I was in a situation where I'm writing something like this and it's simple, I would switch it to a switch statement. But not every if and else if can be a switch statement. It depends on when you want to use it, baby. That's the truth. Not everything is... Even though there's multiple ways of doing it in this case. And so what we're showing is how to convert one if else to... Chris Leon says that they're faster for longer lists, which is also true. So like if you have a big if else, in the background it's faster.
Oh, there you go. That makes more sense.
Okay.
Thank you, Chris.
Forgot about that, Chris. Making me look bad. So in this case, our the next part is we have the answer. I know it's true in Java that switch statements run faster than else ifs. I don't know if it's true in JavaScript. It probably is, though. So we're going to set the answer here equal to oh, no. Oh, this is the answer. Sorry, I misread what I was looking at. So the answer, and we're going to say this is equal to 42. So we're just converting this over line by line. And we'll throw our break in here. And then we'll have case 1. And you see how we have multiple types, right? Not a big deal. And we're saying the answer here is equal to, there is no
okay, so
number 1.
Just to get this straight, so like if the value is Bob, the answer is Marley. So for a case, if Bob is the value,
Yeah.
then the answer is Marley.
Correct. That's what's happening.
Okay.
So the switch is taking whatever's in here.
It would seem shorter because it's passing the value equals, making sure, yeah, because it's like, okay, Bob, okay, Marley. Here in the if statement, it kind of feels like it's saying, okay, we got Bob. Let's see if it matches up with Bob. Oh, it's Bob. Okay, Marley. I just feel like it's faster.
All right, as long as it makes sense for you, baby.
Okay.
All right, so we have case 99, and we want to say the answer is equal to missed me by this much.
There's no objection. Like, you can't write Tom and get the answer. It'll just come back, what, null or undefined?
It won't come back anything.
Okay.
unless you set a default.
Okay.
Same thing with your if and else ifs. It'll check them all, and then it won't do anything. Because none of it's true. Unless you have an else, or unless you have a default. Okay. So case 99, and else, or not else, excuse me, case 7. We're going to say the answer is equal to 8, 9. You get the joke? 7, 8, 9. And now we can go ahead and get rid of all this.
I always thought that joke was really, like, scary. Like, it just grossed me out.
So this one thing is, this is probably easier to read than the rest of this.
Oh, yeah.
It does the same thing, but at the end of the day, it's probably easier to read, and it runs faster. So let's go ahead and get rid of that. And now we run our statement, and we're good to go.
We can take questions if you want. It'll be 50 minutes.
No, we go at the 50-minute mark.
Okay.
So here you see that. All right, so we're gonna be showcasing how we can use the return. So when we return something, we can actually pass. Remember how our statement checks? Like if we say 1 is equal to 2, it will say true or false. It'll return false there, right? We can do the same thing with return statement and simplify our code. So we have this if statement, and we're saying, look, if this number is smaller than this number, return true. So if A is smaller than B, return true, else return false because it's larger than B. Or in that case, it's equal to B. Could be equal to B, still return false. So what we want to do is we want to get rid of what we have here, and instead we can return. All we want to do is return a true or false value. So we can have one line of code where we say return. What do we want to return? A less than B, like that, and it will return true or false. And we've eliminated code, and now it runs faster. So this would be a great example of refactoring.
Let me see the old code. Okay, and then the new code.
Oh. The fuck? Oh, this is interesting. So this actually chains together. So the new code, all we're doing is we're returning A less than B. We're returning the value this returns.
Okay, so you don't actually need an if statement.
Not in this case, no.
How would you know what cases you would need it in?
It would depend on complexity. If all we're doing is one statement, if all we want this function to do is one thing, like let's say we wanted to add them, A plus B, it would return A plus B. In this case, we're checking for a Boolean value. Is A less than B? It can only be two things, true or false. So something that simple we can write like this.
I can't imagine anything being that simple.
Yeah. I mean, what you could do is true or false game. And I say, and we both write down something. And actually, that's a bad example. All right. Well, what we could do is, let's say I can guess your card in a deck of cards. And so you pick your card, I write down a number, and then we compare the two values. Are they equal? If they are, return true. If it's not, return false.
Yeah, but who's gonna use that for a website?
But that's the point, baby. Is you can make anything you want, and sometimes there is things where all you need to do is find out. All you need to do is find. You need to know how all the tools are here, and so this is showing you that you can return things like that.
Okay. Okay.
All right. Modify the function abtest so that if A or B are less than 0, the function will immediately exit with a value of undefined. Okay, so here is asking us to just do a simple test here. So if A is less than 0 or B is less than 0, what we wanted to do is return undefined. If not, if neither one of these is less than 0, we wanted to run this math function, this math data we have, this math return. And you'll see that we have undefined. It's not in quotes because it's a type, right? Hey, Chub Chub.
That's just refactoring?
No, that's not refactoring. What this is this is to kind of this is to set up a statement so that our logic here doesn't break. So the reason that this would break here is you can't take the square root of 0 unless you start getting into like theoretical mathematics and things like that. And there isn't, because it's not real fucking math, there isn't like a math library that can handle that, really. That I'm aware of, but it's traditional math. You probably have to do special things. So in situations like that, instead, we're going to check, hey, if our values that we're going to break it are values that will break it, return undefined, and it never hits this return because you can only get one return in each thing that you're doing.
Okay.
It breaks us out of this function.
Right, okay.
All right. Counting cards. This is a long one, so we can break here. I remember this one. Let's see. All right, guys. I'm gonna stand up real quick.
Not with Milo, apparently.
Are you really that fat that this thing ain't going up no more? All right, guys. So, I know some of you guys asked questions.
Someone's asked if Free Code Camp was a good place to start to be a developer.
So I did a video called "Is Free Code Camp Worth It?" and I answer that in detail in about 10 or 12 minutes. And I highly encourage you to check it out. Minus these live streams, this is my most recent video, and it answers exactly that.
What are you doing?
I'm just moving it. I don't like it. It's off center. It bothers me. But yeah, let's see. There's another question. What do I think about Team Treehouse? I think you get a lot of videos that you probably could get for free on YouTube, but at the same time, there's a lot on there for a relatively good price. I actually signed up for Team Treehouse a while back, and I didn't like what I saw, but I was also very early on in it. So I was looking for something more like Codecoure, than videos on Team Treehouse. So Joshua Jarek asks, hey Dylan, if you could go back to yourself when you were starting your CS degree, what advice would you give? Maybe change the web design instead of doing CS. No, I don't think I would do that. I could see how that would be beneficial to change my degree to web development instead of computer science. But I probably, if I knowing what I know now, and this is a big if, because obviously you can never know what you know now. I would never have gone in the first place. That would be my honest choice. I would instead have gone to a boot camp and done the self-taught developer route, which I've been not very successful, but much more successful in my personal life because of it. That would be the route I would go. But with that being said, not everybody can do that route. It takes a different, like, college is for certain people and self-taught is for certain people and boot camps are for certain people, and not everybody can go down the same route. So you have to decide what's best for you. Now, that's just how it would be for me, at least. Oh man, big boy, are you happy you're up so high? I've had to refactor that out of other people's code more than I like. Yeah, you have to, as a developer, refactoring is part of the process, right? So it's always something. I believe there's one more question that got asked early on. Let me see. If my finger went well-ish, by the way. Stitches are out. Hurt like fuck to get it pulled out, though. Let me tell you, man, because it scabbed over all this sort of stuff. Do I recommend Free Code Camp for wannabe dev? I think Free Code Camp's a great place to get started, and you have to go. You have to go from there. Nick Vandex, I want to see my comment in chat. There you go, man. Stop breaking things, Milo.
I want to see my comment. Totally.
You're world famous now, Nick Van Denberg. Alright, so there's not too many questions. So I will... Should I leave them with a final thought? Do you want to leave them with a final thought? No?
I don't even know what final thought do you mean.
You ever watch Jerry Springer?
Oh God.
Jerry Springer, you ever Jerry Springer, now Tommy Lauren. Get his final thoughts.
Oh my God, what kind of final thoughts?
Wait, like in Jerry Springer, Jerry would. So after all the shenanigans would happen on Jerry Springer, Jerry.
Kitten
So which programming language did you find the hardest? Scala, which is a functional programming language, was the hardest language I ever had. I didn't enjoy it. I didn't like it. I don't remember any of it now. Dylan, do you have a preview of the upcoming Ask a Dev yet? Which Ask a Dev is that? But right now, guys, I've been filming videos daily, Ask a Devs, that I'm going to put up probably this weekend. My finger is, I don't know if you guys can see this, but it's pretty nasty still. The stitches are out of here and here, so I've been kind of holding off. I've been a bit tired as well, but starting Monday, I'll have a video for the next 30 days on top of the live stream. That's the goal. So you'll be seeing lots of Ask a Devs. I might even get around to it sooner. I'm just handling some other stuff in the meantime. How tall am I? I am 6 feet tall. Oh, we got another kitty. He doesn't like the essential oil diffuser. Daddy, turn it off, buddy.
I didn't know he didn't like it.
Hey, buddy. What are you doing? God, don't fucking tear my PC down, Tito. They got a cat attack over here, guys. You got Tito and Milo. You're struggling with JSON and React? That's okay. React just takes practice, and JSON's come pretty naturally once you dive into it a little bit. Yeah, it's good to get it's good to get. It is a great benefit to get good with JSON because all of web development, a lot of it, is dealing with APIs which come back in JSON format, as well as sending objects in and out, which is very JSON-esque as well.
Who's Milo looking at?
I don't know. He's looking like he's about to deep dive onto something.
Milo's wiggling his butt like he's getting ready to like nosedive.
Yeah, just to fix Scala, just grab some Pepsi. You're struggling with iterations on JavaScript? You mean like for loops? Iterating through for loops and stuff? My suggestion is draw it out. Draw the for loop out. Draw out what value for each iteration is supposed to happen, and eventually you'll kind of understand it. I think he wants to get down. That's what he wants to do. And he's afraid to make the jump. Man up, Milo. Alright, come here. You've trapped the cats up here on the standing desk. Just iterations in general, draw it out then. Really, like, get yourself a whiteboard, and we got one right there. I got one in the corner over there, and I got like a 6-foot one right there. I use whiteboards all the time for a lot of different things in coding, and iterations are great for that. Come here, buddy. So what you need to do is understand that each one runs one time, right? And then see each value. Every step of your code, walk through it. If you have one iteration and there's an if statement, another else if, and if, write down the value next to your pseudocode and run through it. And eventually, by the second or third time, you'll have an understanding of how the iterations are working within your code. Don't just expect when you're getting started that you're going to stare at the screen and to get these things. It takes practice and it takes learning, I guess is what I'm trying to say, which is why, like, April and I are sitting here, I'm doing these lessons, going over, and she goes and reworks through it, and even then there's still issues, right? And so you need to not only do this, but you have to do other things as well. Drawing it out, that's not my code, that's April's code over there. And so that's just with HTML. So, alright guys, I appreciate everybody watching this tutoring session, if you will. And what are you going to work on tonight?
Just catch up on notes.
You continue working on the portfolio?
Oh yeah, of course.
So right now, April is back. Milo.
He's
right.
eating one of the statues.
Yeah. Right now, April is reverse engineering the portfolio page on Free Code Camp while doing the JavaScript section at the same time. And then when she's done with the portfolio page, we'll do what we did with the tribute page, which is refactor it. And we'll also, at that point, I'll introduce her to a text editor, which she'll do future code iterations in. And after that, we'll then get into Git version control, and I'll show her how Git works, and I'll explain the concepts to her and what you're supposed to do with it. But that's kind of the game plan moving forward. So it's in the meantime, while she's working on that, we're going to continue going over some subjects in JavaScript, just kind of introduce her to these. My big thing with software is you need to learn by reference. There's so much to learn in so many languages, libraries, and frameworks that what you need to learn is not to memorize stuff, which is one of the unfortunate things about school. It's all about memorization for the most part. Is you actually need to learn by reference, because as a developer, you'll be Googling things, going on Stack Overflow every single day, and you need to just remember that this was a thing, basically. That, hey, what is that thing I was looking for? I'm trying to go and do it. So this is day 7?
Day 8.
Day 8. And it's been a good thing. Copendium, who is Aaron, if you caught the live stream, we interviewed him about a technical interview. The video will be up in a few days. Says, I have another on-site technical interview lined up for next week. They're supposed to be emailing me a specific day and time. Good luck, man. I imagine it'll only take 1 or 2 interviews before you get hired. Thank you, David. And if you guys want to support the channel so that we can get upgraded to 4K content, that's a 4K monitor. I'm trying to raise $300. And after that, 4K webcam as well, so we can do better Ask
Thank you,
Our Devs.
David. Thank you.
And you
Trying. Trying real hard.
You'll get there, baby. You can. That'd be appreciated. Support me on Patreon. And don't forget to join our Facebook group, Code Tech and Caffeine. We're growing by like 20 members a day, something like that. 30 on a good day.
Code Tech Caffeine.
Just like that. All right, baby. You wanna say it?
Code long and prosper.